Good morning, ladies and gentlemen. Welcome to Malaysia International Water Convention 2021. I am Khaw Lip Keong from GMP Professional Sarawak, Sdn Bhd. I will be your moderator for Hall 3 for today. Our first topic today will be smart integrated water resources quality and management. Please welcome our speakers, technologies Adi bin Bakhtia from Alam Sekitar Malaysia, Sdn Bhd.
Okay, Assalamualaikum and salam sejahtera to all. Thank you to Chairman and also Malaysia International Water Convention 2021. Today, I would like to talk about smart integrated water resource monitoring and management in Malaysia. Before I start, my name is Adi Bakhtia. I'm the General Manager Sales for Alam Sekitar Malaysia, Sdn Bhd. Recently we are facing a few cases of the pollution event happen that caused our treatment plant shut down. It happened in multiple states in Malaysia. Example like here I show in the slide. We have 4 treatment system shut down due to diesel pollution event in the Selangor area. And then we also have a few cases in Johor. So whatever we do right now is a reactive action rather than proactive. Whenever we are facing the problem, then we take action. So that one is categorized as a reactive. So what we do right now is crisis management. So we take action due to some crisis happen. What we're going to do what we are going to do later, it should be risk management. So we need to come up with the plan or program to predict and then have a program for prevention, mitigation, and our program for to take a look on our preparedness if pollution event happen to overcome our water disruption in Malaysia. What ASMA can offer, what ASMA have experience. We have experience in smart water monitoring. We can install, monitor water resource at the beginning of the source, at the dam area, at the ORS, stand for off river storage. So what we can do here, we can do hydrological monitoring, we can do water quality monitoring. Also, we can do the dam structure monitoring. So this one at the beginning of the source, we should install and monitor our water quality, hydrological quantity, and also dam structure. After that, in the river stage, at the river area, we also can install our river monitoring station. So in here also, we should monitor hydrological parameter and water quality parameter. On top of that, we also can measure pollution loading to make sure our pollutant level enter the river system is still under control. In terms of the industry, in Malaysia we should start with the enforce the industrial continuous and industrial effluent monitoring. Quality monitoring. So currently we have a manual kind of monitoring. So we need to take samples, send to the lab, and then get the reading, and then report back to the DOE. But we should move one step ahead, one step further by using a continuous effluent monitoring system. Why we need to use this one? So because we need to get the fast reading rather than monthly reported monthly reading or data. Okay. After that, we can install domestic wastewater monitoring. Currently, all the STP system or treatment system discharge to the river, we monitor by manual. So every month they must take a sample, send to the lab, get the data and report back to the relevant authority. But for domestic wastewater or any kind of wastewater treatment system that have a discharge to the river system or water quality system should be installed with the continuous type of monitoring program. Okay. After that, if we're looking at this distribution water distribution system, our potable water, okay. Currently, in Malaysia, one of the state already started the distribution water quality monitoring system. Here, they monitor the water quality in our pipeline. Okay, so on top of that, also monitor hydraulic monitoring. So we can get how much pressure in the pipeline, how much of flow in the pipeline. Okay, this one, with this monitoring, we can also monitor leakage. So by doing leakage monitoring, this one, we can identify where potential of pipe burst location, and then this one can reduce our NRW. Okay. 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 Last but not least, we also should consider to install distribution monitoring, water monitoring at the end of the distribution pipeline, distribution center, distribution line. So here at the almost at the housing area, we need to install sensor that can give the online reading in terms of the water quality. And then also currently a few states already start with the smart water smart meter. So this one smart meter can be integrated, all the information can be integrated to the data center. Okay, here also we can monitor the hydraulic parameter, similar like in the middle of the distribution system. Okay, whatever system that we install to monitor either water quality, either the ground hydraulic, it should be transmit to one data center. So we should call the environmental data center. All the groundwater quality, lake, river or pond water quality, odor, industrial outfall, effluent should be all together integrate to one data center. Okay, why we need this one? This one because all the data should be integrated to the one center and will be transmit for purpose of compliance and enforcement. So the relevant authority can view the data, can verify the data, and then if they have a non-compliant, so the enforcement can take very fast action. So if they have a pollution event, so pollution event can be, so the authority can take the fast action to investigate the pollution event and to identify who will be the polluter. Okay, and then to assess the prevention and control of a pollution happen. Okay, so from the data center also, we need to the data can be displayed to the public. So can public, when they know the water quality status, they can do complaint if they have facing any or they saw any pollution happen or any non-compliance. So they can report the complaint to this system, to the data system. Okay. Whenever we show data to the public, so the public can easily access all the information. It can be from the water quality, it can be from the status of the pollution or status of the water supply. Okay. Here, if they have any pollution event happen, So the early warning can be sent out automatically to the public to give a warn to the public to take a certain action. Example, to storage the potable water, adequate potable water for their own usage. Okay, for others, for the investor, for politician, the stakeholder can also get the data or information from this data environmental data center for their own purpose, maybe for planning, for investor, okay, and others. So this environmental data center should have capability to give the early warning system and also to compile all the data to the one place using the data center. Can report any of index. Example here is air pollution index or water quality index online. Okay, should able to do some forecasting or prediction. Maybe a short-term prediction. On example like here is water quality forecast, water quality simulation. If they have cases of the pollution event or before the pollution event happen, we can do the simulation how far severity of the pollutant can travel. Okay. Also, we can integrate with the environmental consultancy services and also GIS. We can compile together with the GIS to identify where the location of the pollution inventory to compare with the pollution inventory information. Okay, currently is we do monitoring, environmental monitoring as services, but we should consider in future we should consider a software as a service. So in ASMA we have combined this environmental monitoring and a software become ASMA Integrated Environmental Information Monitoring System, what we call AMIS. So its basic architecture is we have a station, multiple station, all the data is transmit to the smart data logger, and then data logger can be transmit to the either cloud system or physical data center, and then the data center can be equipped with the relevant software and automatic data validation system. Okay, this data center must have the data backup system or redundancy in case of one data center is have a problem, so we backup with another data system. Okay, output from the data center should be real-time dashboard, early warning system, reporting analysis, okay, forecasting and modeling, security management, and also integration with others system. This all the data can be transmit or can be viewed by all stakeholder. Okay, in this case can be the authority, can be the investor, can be the public. Okay. The data center also can be integrated with the GIS to identify the point source. So the point source inventory should be integrated with the data system, database system, to give the better prediction. Okay. This one is just the typical diagram of a continuous water quality monitoring station. So the sensor should be installed inside the water body, and then have cables in the cable to the station itself. Inside the station should install the auto sampler. So in case of the pollution event, the auto sampler have capability to retrieve to take a sample from the river and then storage in the auto sampler. The auto sampler can be refrigerated or a portable type of auto sampler, and then the data is connected to the data acquisition system or DAS, and then this data acquisition system should be able to transmit the data to the cloud or the physical data center using either GSM or any kind of protocol. Okay. This one just an example of a few station we install for multiple client. at the river to monitor either water quality or also water quantity. Okay, the design is depend on the client and also the suitability of the site condition. Okay, the river bank type, the soil type, the flow, river flow. So the design is depend on the client and also the suitability of the site. Okay. We take example for river pollution load monitoring. We take example this one data from the DOE back to the 2017. In here we can see a lot of the river in class either class 3 or class 4. Is class 5 we have one river at Johor, Sungai Tukar Batu at Johor at the Pasir Gudang side. So we see here is more than 10 river is class 4. This more than 10 river class 4 is not should use for any water supply. So if we looking at the DOE classes, the class 4 it should be able to use for irrigation. So some of the here is quite familiar river. Okay, we take another example is a river class 3. Okay, this one require the intensive treatment system. We see here is already have 24. Okay, 24 river in Malaysia that under the class 3. So all this river is required an intensive treatment system to treat to become the potable water to suitable for what drinking water. So in the river pollution load monitoring, assimilative capacity of river need to be considered. What is the assimilative capacity? Refer to ability of natural body of water. It can be lake, river, or sea to clean itself. Okay. The capacity to receive wastewater or toxic substance without harmful effect or damage to aquatic life and human who consume the water later on. Okay. If the pollution load is less than assimilative capacity, then the water quality should be maintained, can be maintained. But what happens if a pollution load is greater or more than assimilative capacity of the river? So we can see, we can predict the water quality can be impaired for the longer time. Okay. We take one our case study in Malaysia. Thanks to Badan Kawasan Air Johor, we take theirs one of the river monitoring station to do our pilot. In here, we do a river pollution load analysis system. It's an online river pollution load analysis system. Okay. This system we install, we attach together, the software is attached together with the river monitoring system, and then the data can be transmitted to one portal and then combined with the software, they can give the pollution load, real-time pollution load, and then we compare with the class that we require. In this case, maybe we can use a class 2 or class 3. So all the dots show the real-time loading for the particular time. Example here, we took the class 2 as a baseline. So whenever the dot show the data show above than the graph, means they already non-compliance to the limit that we set, we targeted. So, and then also the system also can be divided or can segregated to two potential source. It can be non-point source and also a point source. This we categorized by the discharge regime. Okay. Okay. This the system can be integrated with the GIS to map out on the pollution source and non-point source. Okay. This one to predict of the non-point source pollution loading or modeling. Okay. By this having this river pollution load analysis system online, so we can give an early warning system. Okay. Basically, what we do here is a online river pollution load analysis system is the digital twin or alternative or complement the normal or conventional TMDL what we do to one every single river. Okay, this is our study. So we overlay with the GIS or pollution source inventory or information. We have 3 stations here. We have Sungai Sayong, we have Sungai Johor and Sungai Semangga. These all the river monitoring station located. So we overlay with the pollution sources. If any case they have pollution, maybe from the system can identify or give the alarm if American nitrogen, example, American nitrogen have breached the loading limit, so we can identify which polluter or pollution sources that can cause the high potential, give the high reading of American nitrogen. Okay, I think that's all about the slide. Later on, if you have any question, you can email to me or you can contact us, Alat Sekitar Malaysia for further explanation. Okay, thanks again to Malaysia International Water Conference for this opportunity. Okay, thank you.
Thank you. Thank you, Mr. Adi. It's a Q&A session now. So is there any question the audience want to ask? And please send put at the chat box. We'll pick up and then we'll moderate, and then the speaker will answer whatever he can. So no question at the moment. Maybe I have one question, Mr. Adi.
Yes, sure.
The water river quality that you have been collected the sample and the analysis under the ASMA program, I think quite some time, as you mentioned just now. We also having a lot of problem on the water quality. Some of the treatment plant have to shut down from, because of the pollution, and some of the rivers have quite bad polluted, and recently happened in Johor and some other states. Now, with all these issues, where are we actually in terms of the good water quality governance or water quality comparatively to other parts of the country? Where are we now actually? Because sometimes we look at some other place, we travel, we look at the river, it's also quite dirty, quite muddy, but when we come back to our country, we have this pollution issue as well. Actually, please, if you can give some indication, Sadi.
Okay. Thank you for the question, Mr. MC. Basically, if we looking at the trend, the water quality in the river in Malaysia is deteriorate years by years. The numbers of the polluted river increasing. One of the reason is because of the development increasing. Increase at the populated area, and also we need to improve our monitoring program. As I mentioned in my presentation, currently we only do monthly checking. We take a sample monthly, once a month, and then send to lab, and then we report to the authority. So that data reported to the authority is at least 1 month behind. So whenever we get the data, so it shows something. It shows either non-compliant or compliant. So during that time, the past already passed. The pollution already happened. That's why I strongly advise to authority to do this one step ahead, to install or to initiate the online water quality program for for all discharge, wastewater discharge, either domestic or industry, to the river or water body. By doing this, we can identify straightly when because the online program is measured every 50 minutes. So every 50 minutes we get the data and show compliant or non-compliant. So by doing that, we strictly know the status very fast, and also we can take action to at least to identify who will be the polluter and take action against them. Okay.
Thank you, Sadi. Any question from audience at the moment? Okay, Sadi, there's one question from Jabatan Bekalan Air Luar Bandar Sarawak, Engineer Azizi. The question is, what sensor accuracy do you recommend for the quality monitoring? I mean, it's raw water quality, obviously.
Okay, thank you for the question from the Mr. Azizi from the JBALB. Okay, basically, normal acceptance, we're looking at 5 to 10% different, or 90 to 95% accuracy of the equipment to be is compared to the lab analysis. But the challenge here is how to maintain that equipment to be continuously or continually provide the higher accuracy, because the maintenance is part of the program. Maybe we need to consider some cost of the maintenance part of the program, not just the purchase and install and then leave it there. Okay.
Correct. Yeah, I agree. I think the bulk of it is quite a fair bit of the maintenance money that can have to come together with the whole to solve the problem. There's another question, Sadi, from Trina Lorita. How does the system determines the assimilative capacity of the river?
Okay, good question from the Trina Loria. Basically, before we come up with the system, we need to conduct the assessment. We need to take a sample from the loading of the river, pollution loading of the river, rainfall data, put in one software. Then the software can do calculation, automatic calculation. What will be the assimilative capacity for that river or that particular site? Okay. So when we show to you, just after we don't show the background of that software lah, basically. So behind that software, all the data must be generated or obtained prior to publish the output, like I showed to the slide just now. Okay.
Right. Thank you, Mr. Adi. If there is more question, I would like to invite the audience to send your questions to the email. Look at our conference website and send an email. Put a whole tree. We attention for the whole tree. We will take up from there. Mr. Adi, last question from me. The World Rivers Days is fixed at in I think third Sunday of September every year. So I think your topic is quite on time, talking about the river raw water quality. So what is the last statement, or perhaps a certain the important message you probably would like to share with us for the this upcoming weekend World Rivers Days for 2021?
Okay, thank you. My last word for me, basically, water is our business, everybody business. We need to live, we cannot live without water. So water is everybody business. We need to maintain our water quality in terms of quality, in terms of hydrology, quantity, because it affects us. Okay, we need to take part, small or big portion, doesn't matter. Everybody need to contribute something to preserve our water quality in terms of river water quality, ocean. Like just now, because of open out of the PPN, everybody go to the beach and throw the rubbish. So everybody contribute to the become worse. It's not become better. Okay, I think that's all for me.
All right. Thank you, Technologies Hadi, for your time. And I have to conclude this session. As I mentioned, if any more questions from the audience, please send an email to us. We will respond to you as soon as possible. With this, thanks again. Thanks everybody, and thanks the speaker. We conclude this first session this morning. We will be back another half an hour from now, 11:30. Sorry, 11:15. We have another session. Thank you very much, everybody. Thank you for your participation. Bye bye.
Thank you all. Thank you.
Yeah.